So today we're going to talk about chapter 17.1, which is all about mechanical waves. And remember, the word mechanical in science has to do with movement or moving parts. So a mechanical wave is created when a source of energy causes a vibration to travel through a medium. What this means is there's a source of energy that causes particles inside a solid, liquid, gas, or something like that the medium is. And those vibrations of the particles are what transfer that energy. And that transfer of energy is the wave. So an example of this, whenever we hear the word waves, people usually think of ocean waves. So in this case, there is energy that is making these water molecules move up and down and side to side, and they create these waves in the water. And in this case, the water is the medium. Now, there are three types of mechanical waves. There are transverse waves, longitudinal waves, and surface waves. Transverse waves are usually the ones that we think of when we think of the shape of a wave. It's a wave that causes the medium or material to vibrate at a right angle to the direction in which the wave travels. So this picture shows a rope being shaken up and down. And you can see that the rope itself, if I take one spot on this rope and I focused on that one spot, you would see that one spot move down and move up as the hand shakes the rope. But the energy coming from the hand and moving through the rope moves in this direction. So you can see that these two lines are perpendicular or at 90 degrees to each other. This is a transverse wave. Some examples of transverse waves are ripple waves in water. Whenever a drop of water is dropped into a pond or something, those resulting waves, they cause the water to go up and down, but the energy moves to the side. And so that is an example of a transverse wave. Another example of a transverse wave is a guitar string. And this picture is interesting because this is not actually how guitar strings work. They do not vibrate in a way that looks like this if you take a picture. What happens is they vibrate from where they're attached at the top of the neck down to where they're attached at the bottom of the neck. And they vibrate like that, or they can vibrate like that, or they can vibrate like this. But they vibrate up and down. And they don't actually look like this picture, but they are still a form of transverse wave because the energy that is transferred through the string when it's plucked with a finger or a pick goes from one side of the string to another. It travels this way. But the string itself, the material, travels side to side, which is at a 90-degree angle. Another kind of mechanical wave is a longitudinal wave. And these are kind of weird to think of because they're hard to visualize. But a longitudinal wave is one in which the vibration of the medium is parallel to the direction in which the wave travels. So this is a picture of a longitudinal wave. And this is like if we took a slinky and stretched it out across the floor, and then one person bunched a little bit up so that it was stretched out and then let go. What would happen is at parts of the slinky, the coils would be really tight together, and this is what we call compression. And at other parts, the coils would be really far apart, and that's what we call rarefaction. And as this happened, the parts of the slinky, like the particles of the slinky, would move back and forth like this as the wave came down and back. The energy of this wave also moves in this direction. So the movement of the material is in the same direction or in the same plane as the direction of movement of the energy. Examples of longitudinal waves are sound and P waves that are earthquake waves. So sound is actually just a compression or a rarefaction of air. So as I'm speaking, the air molecules between my vocal cords and the microphone on the computer are being squished and stretched and squished and stretched back and forth, and that is transferring the energy from my vocal cords to the microphone in the same direction. Now, a P wave is a type of earthquake wave that happens deep, deep underground, and the ground will actually shake back and forth. It will compress and rarefact, and it will go back and forth as the energy travels in this direction. And a cool fact about P waves that I actually just recently learned is that we cannot hear them because they happen at frequencies which our ears cannot hear. But some dogs can pick up P waves. And this is why scientists think that dogs start freaking out and they will start barking and going crazy a few seconds before we feel an earthquake hit. It's because the P waves have actually hit at that point and the dogs can hear it happening, whereas we cannot perceive the P waves coming through. We can only feel what's called the surface waves. And that is the third type of mechanical wave. So surface wave is a wave that travels along a surface that separates two mediums. So there are surface waves that could be between air and water. There are surface waves that can be between water and a solid, like ground. And what happens is not only does the material move side to side, like in a longitudinal wave, it also moves up and down, like in a transverse wave. And so an object that is sitting in a material that has surface waves running through it will actually move in a circle. It will first move to the side and then be pushed up, and then it will be pushed back in the opposite direction and down, and it will bob in a circle. So it's kind of a combination of the two other kinds of mechanical waves. So here are your homework questions, page 503, questions 1, 2, 4, and connecting concepts. Please finish these up and have them ready to turn in tomorrow.